Hello guys, welcome to another video of Electropreneur. In the last video we were discussing sinusoidal waves and how we can make sinusoidal waves, and then we briefly discussed how we can change the how we can see the waves better in MATLAB. We use a few tools like Axis. If you haven't seen that video and you are still figuring out how to make use those tools and you want to know, go in the description and there's a link to my previous video. However, today we will be discussing very specifically the square waves. Today what I'm going to do is, we generated sinusoidal waves in the last video, right? Today what we are going to see is we are going to implement square waves in two ways. First, we are going to take some sinusoidal waves, add them together and see how can we make a square wave from sinusoidal waves. And then what we are going to do is we are going to implement a square wave from in a different method by using some function or something or similar to that. So guys, without further ado, let's move on to the video very quickly. If you have any problems of your own, as I said in the previous video, I'll say it again, drop it down in the comment section. I will help you out in the best way I can. Thank you. Let's go on to the video.
Alright guys, and the first agenda of my discussion would be how can we make a square-like function using the fundamentals of sinusoidal wave. Why do I say fundamentals? What is actually happening here is we're taking the odd fundamentals of a frequency of the sinusoidal function and we are adding them together, and that is giving us a square-like function. Why do I keep saying square-like function? You will see that in just about a second. However, I just want to discuss the code that is written in front of you on the screen. The reason why I'm not typing all of this code for you people step by step is that these are sinusoidal waves, and we have discussed the sinusoidal waves in our previous video. If you have not seen that video and you are having troubles, I would suggest that there's a link in my description to my previous video. Go check it out and then come to this video and you will understand everything. So guys, in this you can see that the odd fundamentals of the sine function are being added together, and if you want to know the function that is enabling this, it's pretty simple. In that you just the basic concept one is 4a by pi, and you multiply it to the summation of 1 over n. Basically you can say that sine omega t divided by pi. In actuality, in in layman terms, all that function is doing is telling us that the odd fundamentals summed together will give you the square-like function. And remember guys, the problem that I'm going to show you right now in just about a second. Let's see the wave first. Okay, now you see this kind of looks like square wave except for this part, right? This part we see there are a lot of they are like sinusoid functions, but not a horizontal line like in square wave should have. This is called Gibbs effect or Gibbs phenomena. The thing is, this happens due to discontinuity, and you can fix this in a certain manner, but you can't properly get a very very smooth horizontal line. To get that smooth horizontal line, you need a lot of odd components of a lot of them you have to add together, and then you will be able to get that. So the solution to this is you add more and more you add more and more odd components together, and these start to plateau out and start to look more like a square function. Let's go ahead and do something like this first. Let's add another one, right? Let's see if it does anything. Okay guys, let's do this. So the function is called square. Okay, I mean, yeah, I know its name is square. And now what we are going to do is, there are two functions here. One is the simple square. What you do is you write 2 and you write pi, and then you give the frequency multiplied by time, and it just gives you a square wave, right? Let's first let's see that. Let's just take these two from here, put them here, and see what happens. Let's just keep this like this first. Okay, we can, oh sorry, just 1 second. Still not that good. Let's just put it on 0.4. Somewhat better. You know, I just make it from -2 to 2. Okay, that's a lot better. Now there is a problem here. Actually, there is no problem in this function, but I want to propose a problem here. What if you want to know a wave, or you want to generate a square wave, but you also want to control the on time or off time, in more better words, the duty cycle of that wave? Then what will you do is, you will use this same function. However, in this, now I would like to explain the function a little better. This is 2, this is pi for omega, and this is t. This is the frequency, right? What you are going to do is, you just going to put a comma here, and you are going to give the duty cycle here, whichever duty cycle you want. Let's say I want 80% duty cycle, or 50% duty cycle. Whatever the duty cycle is, I'm going to put it here. For the sake of understanding, let's first generate one with 50% duty cycle and see what happens. Okay, not really different. So let's put here 10% duty cycle, right? That will be a bit more different. You see, the on time is only for 10% of the time period. This is the 10%, and similarly, if you want 80%, you can change here and write 80%. 80%, and it will, generate one where the on time is for 80%, the off time is for 20%, and so on and so forth. You can go from 0 to 100, and you can set any duty cycle in between. So now the problem that I want to discuss, another kind of command here, that is called a duty cycle command. What that command is doing is, basically, if you have a square wave and you don't know what kind of duty cycle does it have, what's the duty cycle of that wave, you want to find it out, you can simply use this function and give it the okay. And this is the function duty cycle, just like this, and you give it the function and the time that you have set over here, and what it does is, it will give you, okay, this is a bit odd. Oh, sorry, this is the one we were working on. Okay, what we are going to do is, we are going to see this. What it simply does is, you give it the function and we give it the time of this time of the function, and let's see what it let's just put it in a variable called duty. Okay, what am I doing? Okay, let's see what happens, right? Now, in the beginning, we said that our we set the duty cycle or to 80, right? Let's see what our, so it's on every point it's calculating the on every trigger it's calculating the duty cycle. It's 79%, 80, 79, it's almost 80%, and that's how the function is telling us that it is 89. If we just do this, it's going to give you a singular answer instead of making a double array. Or no, it still gets that same answer. You can change the duty cycle here and check it out. For sake, I would do this. Let's see if we generate a wave for 30 Hz, and what is the and also remember, on default, if you don't give any duty cycle, it keeps the duty cycle at 50%. That's why the first time when we placed 50%, it was the same. You see 49, 50, 50, 50, 50. Why it is saying 0.5? You have to actually multiply it by 100. If you see the duty cycle formula, it's actually the difference between time upon time period multiplied by 100. So that's the percentage. That's why we say 20% duty cycle, 30% duty cycle. So if you multiply this by 100, it's actually 50. So okay, alright guys, this was all about the square waves and the fundamental summation of fundamental to produce a vector that gives the shape of a square wave. If you have questions about if you have questions about this video, previous video, or any other problems that you want to be solved, please do give the problem to me in the comment section. Ask me the problem in the comment section. Ask me questions in the comment section. I will do my best to answer them and help you out to the best of my abilities. With that said, if you like this video, if you found